Okay.
Pierre, good luck, and I wish everybody to enjoy the workshop from Pierre.
Thank you. Hey everyone, we are not so much, so it's like a private class directly for you. So if you have any question, please interrupt myself. I will. There is not so many people, so questions are really welcome. Today I will show you Polkadot standard proposal, especially the standard for the WASM smart contracts. I'm Pierre. I work at Astar as a WASM developer, and since some months, and I'm really glad to show you this. So there is different Polkadot standard, but today we will only focus on the three that are for smart contracts, WASM smart contracts specifically. The standard were created by Super Colony. I worked there before entering Astar, so I also worked on developing their PSP with them. It's validated by all the community, of course, in a Web3 Foundation repository that we will visit just after. There is PSP22, which is a ERC20 equivalent, which is really known. I think everybody know it, which is a fungible token standard. PSP34, so the NFT standard, ERC721 equivalent, and also PSP37, which is multi-token standard, so the ERC1151. I think you're all wondering why PSP22, 34, 37. It's because it's the number of the pull requests in the Web3 Foundation PSP repository. So PSP22 was 20 seconds pull request. So that's why the number can be really different from the one in Ethereum. Why do we need smart contract standard? Yes, someone was talking. No. Okay, why do we need smart contract standard? The first thing and the most important is to enable interoperability. It's because under the hood, when you do smart contracts calls, it needs to respect the exact same interface, which is a function name. And only by this, you can enable cross-contract calls. So imagine everybody was creating his token with a different interface. You should have one function to call every different token. So it should be almost impossible to do all this adaptation for every token that are deployed on the network. Also for wallet, they also communicate directly with the token name, so with the function name. So it's way more easy for them if everything is standardized. As well for libraries and SDK, you do, for example, in JavaScript that you use directly for your front end or your wallet, it's the same. They also need to have a standardization of the name in order to communicate directly with the smart contract. Also, it fosters security because it ensures there is, of course, the standard is at interface level, and you can have as many implementation as you want, but still, this some implementation will be audited, and then it ensures the security of the smart contract. And as I said, the growth, it's because if you have in the network only smart contracts that are standardized, it's way easier to develop a DApp. For example, DeFi will be way more easier if you have only standardized token in the network. If there is question, please, guys. So why does this standard targets they target specifically WASM smart contract on pallet contracts. So they are not like inherent to EVM. They really target only the pallet contracts. What is pallet contracts? As you may know, there is the substrate, which is the development framework to write a blockchain, and every parachain on Polkadot on Dotsama is based on substrate, and one of its pallet, which is pallet contracts, it's a runtime environment for WASM smart contracts. It has a certain specificities and API. So those PSP only targets these pallet contracts, but these pallet contracts can be added to any parachain that wants to have WASM smart contract capabilities. So you can use this PSP on this network. Any DSL is supported. There is a famous ink, but it's not only on ink, because it's at ABI level, means that you can use ink. You can also use ASC or any smart contract language, as long as when you compile your smart contract, the IBI is respect the standard. So inside the PSP, what a PSP define? The most important, I think, is the interface function. So as I said, to enable interoperability, sorry, I don't know why it's hard to say, all function need to have the same name, exactly the same name. That's what we call a selector. Also, they can have an optional extension, and it's also part of the standard, because many team will use it. So it's better if those extensions are also part of the standard. Also, all the event that could be emitted and all its fields, because front-end and block explorer and block indexers only works also with libraries. So it's way more easier if the events is also, if the event name and fields are also standardized. The type that are used in the contract, especially in the return statements, and also all the error, which is all the error that can be emitted from the contract. So I give you two links. I will share you to use this presentation in the chat. So the Web3 Foundation PSP repo, where all PSP lives, and also OpenBrush, which is also developed by SuperColony, which serve as the Open Zeppelin for WASM smart contract. So they created the standard, but in OpenBrush, you have the reference implementation ready to be used in your contract. Okay, so let's dive in the PSP. I hope it's big enough. So we are in the PSP repository of Web3 Foundation, and we have here PSPs, and here you can see PSP22 and PSP34, which is right now the only two Polkadot standard. So not only as smart contract on the wall Polkadot ecosystem, these are the only two standards that were validated, and the other one is in draft. The standard for multi-token is in final state, but it's still not, it still needed the final validation. So it's still in the draft folder and will come here when it will be fully validated. PSP22, so the ERC20 for WASM smart contract, fungible token standard. So the summary and motivation, this is what I already presented before. So let's go directly to the specification. As I said, it's at ABI level. So I will present what is it. And I want to explain why. It's because we should have done it directly in ink and do an ink standard, but then we will restrain only by the usage of ink. But we know that as long as a language can compile to WASM, then you can deploy with this language on pallet contracts. And we don't want to couple this standard only with ink. We want to do this standard for any contract that can be deployed on pallet contract. So basically, as long you can use ink, ask, or everything, as long as it respects this ABI, which is basically the metadata format, it's good to go. So the PSP22 interface. First, we have a total supply. So this is what metadata looks like. So the ABI. Under the hood, when you do a cross-contract call, smart contract use selector. Selector are also used in Ethereum. So it's something we took from Ethereum. And it's basically the Blake2B hash of the trait name and the function name. So if I take this and here I check here Blake2 a string of 256, and I take the first 4 bytes. Here this is a selector. So here you have the selector. So this one should be, of course, there is a hard, you should definitely respect this, or the cross-contract call will not work at all. It takes no args, so the args array is empty. Then you have the docs, so documentation. Mutates, it's here total supply only, it's a query, so it does not mutate the state. There is a name, the return type, which is a balance, and after in the type we will see that balance is a U128, and the selector. And don't worry, this is when you develop a smart contract. Of course, this is automatically generated when you compile your contract, but just you need to be sure everything is respected. So balance off to get the balance of the owner, allowance, so to query the allowance of an owner and a spender. Basically, all the format is all time the same, so I will not go through it. So of course, transfer, this one return a result, so it can fail. There is a sufficient documentation. Transfer from, approve, increase allowance. So this is, for example, this is not part of the ERC20 standard, but as right now, it's pretty much used by any fungible token, we decided to add it directly to this PSP22 standard. Of course, decrease, because we added it because it used less gas to increase, decrease, and to call again allowance. There is also, as I said, PSP22 metadata, which is an extension. So you can have a token name, token symbol, and token decimal. There is PSP22 receiver. It's also work as the one in Ethereum. What is it? It's basically in your contract. Every time someone wants to transfer to your token, you can, for example, override before token received. So this one, and then send an error. So for example, if you want to pause your contract and then restrict anyone to send you token, then you can do it. So it ensures when you send token that the contract is active. Before received is part of the standard, but there is also after received, which is not part of the standard, but is part of OpenBrush PSP22 implementation. So it's also really handy. So the event, really basic. So when a transfer happens, when there is an approval, and the type account ID, which is exactly the same account ID as substrate-based blockchain, and the balance, when it return balance, it should be a U128. The return type, so this is pretty ugly to read, but for a machine, it's really easy to read. Basically, this type one is just as a result, because we decided to use result, but result, it's pretty much Rust centric, but of course you can create result type in another type, basically in any language, sorry, in TypeScript, JavaScript, C++, C#. You need to recreate the return type in order to meet the specification of the standard, and everything is described here. And here you have all the error, and then the error. So all the error that can be thrown by the contract are here, and for the receiver this one. So that's all for the PSP22. I went a bit into detail, but I will make it more fast for the 34 and 37. So the NFT contract, PSP34. What is it inside? Collection ID. So this one is to get the ID of the token. The balance, of course, number of NFT held by an owner, the owner of a certain NFT. Of course, you can also give allowance for a certain NFT, and of course approve, and of course transfer from. There is also receiver, so same thing as is in PSP22. And you have PSP34 metadata as extension, and I want to explain you this. It's explained here. So in this standard, NFT standard, we don't use token URI. There is a reason for this, is that token URI was part of the first ERC 721 standard on Ethereum, but it become really, this dependency become really hard, because if you do an NFT for digital art, and if you do an NFT for, I don't know, like a ticket, entrance to a concert, or if you do an NFT for a soulbound token, then your token metadata, token URI will be different. And we don't want to restrain this standard to any NFT usage. So we added what we call attribute. Basically, it's a basic key value attribute, and you can define by like any attribute you want. By default, there is no attribute at all. And then you can override set attribute to set attribute. But then usually an attribute should not be changed. So it's only on a really specific case, but you can get attributes if you pass the ID of the token and the key. There is no method to get all attribute for all the token. I think it's more easy like this. So event, it's like PSP22 almost. There's transfer, approval, and of course attribute set, which will be called every time you create a new NFT, because it will have attributes. Then the ID. In Ethereum, the ID is, of course, U256. But here, we didn't wanted to restrain the ID to be something, because, as you know, space is, you pay for every space you use on chain. So basically, you can create an NFT and choose the type of the ID. So if you will mint like less than 255 token, then it's better to use U8. And if you want to mint more, you can actually choose which one you want to use. So it's really flexible. Account ID is the same. Type, it's the same as PSP22, but of course the error are not the same, but it's also the result enum. And the error that can be emitted, not emitted, sent by the contract, PSP34 contract. So that's all for PSP34. And now the last one. So here it's PSP35, but there is a pull request that will change it to PSP37. They added something. I will not cover it. If you want to check, you can check. So it's a multi-token standard. So you can basically create a collection, and if you want it to be a NFT, you just say that this collection have only one token, and if you want to create a fungible token, you just create more than one. So of course, balance off, and the ID here is exactly the same as the ID in PSP34. So it's an enum where you can choose which one you want to use. All the methods are pretty much the same, but of course, for example, for approve, you have the ID, but you have also the value, because if your token ID is a fungible token, of course, you should provide a value. If it's an NFT, value is 1. So there's transfer from, it's pretty much the same. The PSP35 receiver and the extension getter attribute, the same as in NFT. And there is something new here, is batch, PSP35 batch. So it's an optional extension, but it should be part of this standard, because many people will probably use it. and then you can directly pass an array of ID balance to transfer, and it will cost you way less gas than calling transfer and transfer from as many times as you need to do a transfer. So there is batch of transfer, and there is of course batch of transfer from with ID amounts. Event, so transfer batch, which will have an array of all the transfer. Approval, attribute set same, and ID, account ID and balance. Here we need balance because it can be fungible. Return type, the same, and the error that can be emitted from PSP35, which will be PSP37. Okay, that's all for me. I don't know if there is a question.
Okay, guys, if you have any questions, feel free to drop it in our chat. Let's wait maybe a few minutes. Somebody will come up with any interesting question to Pierre.
Okay, guys, so thank you all for your attention. I hope you enjoy it, and it was not too fast, but I think it was just an intro, so feel free to check it and check the implementation directly in OpenBrush if you know Rust and Ink.
Awesome. Thanks a lot one more time, Pierre. And I would like to remind you that tomorrow, the same time at 6 p.m., we're having another workshop. So I'll be glad to see you there as well. Enjoy the evening, everybody.
Thank you, Guy. Bye.